Right, do you want to mute yourself, Mohammed? I can just hear you shuffling.
All right.
Right, so what we're going to do is we're just going to do a bit of a recap on osmosis, right? So what we can do on my new board that I have no idea how to use. Okay, so what we're doing is osmosis. Okay, so osmosis is the investigate or the actual practical itself, but osmosis is the movement of water from a high concentration of water to a low concentration of water. And what we did is we went through the independent variables, the dependent variables, and the control variables. Now you should all have this written down. Independent variables are what we change, right? So what we're changing, right, between each one is the concentration of sugar. So here we should have, make the board work properly. And we should have concentration of sugar. Right, let's see how good at this. Okay, concentration of sugar. The dependent variable is then what we measure, right? So that is then basically the size of the potato. The control variables is then everything else. So it's the test tube you use, it's the temperature in the room, it's the volume of the sugar, it's the size of the potato at the start. Okay, they're all then the controllables, which is then written here. We went through this practical here, right? And this practical then, you have a beaker, you have a sugar solution. So there's your beaker, there's your sugar solution, there's the potato that you put in, right? And the potatoes then are all exactly the same size. Cork borer is then the thing that you're actually making the little tubers of potato with. You've got a knife to then make things exactly the same size. And you've got an electric balance to weigh all the different bits of potato. Right? We went through all that last time. Then what we did is we watched a video, right, the Malmesbury science video, and then we went through the method. So, method number one, cut the potato cores to 40 to 30 millimeters using a borer and scalpel or knife. Number two, using the electric balance, weigh the potato cores and record their mass. Okay, that's important that you record the mass accurately. Number three, place the potato cores in different sugar solutions overnight. And we do it overnight so that then osmosis has then got time to work. Once it's happened for 24 hours, pat the potato cores dry with a paper towel and re-weigh the cores. And you pat the potato cores dry because when you pull anything out of water, it's got kind of got excess water on it. What you have to do, you have to pat it dry because when you weighed it the first time, it didn't have the extra bits of water. Then what you do is you record your results in a table, and I'm going to be going through the table in a minute. Okay, now this little video, right, is free science one, right, and what I want you to do is just watch this.
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how to investigate the effect of osmosis on plant tissue. You should then be able to calculate percentage change. This is all quite practical, so it's important that you know the details. In the last video, we looked at osmosis. We saw that osmosis is a diffusion of water from a dilute solution to a concentrated solution through a partially permeable membrane. We saw that when a plant cell is placed in water, then water will move into the cell by osmosis, and the cell will expand like this.
Right, so what it's talking about there is, if you've got a plant cell, right, that plant cell, right, I can't write on that, right, what the plant cell does is it's got higher concentration, lower concentration of water inside, higher concentration outside, so the water then goes in. And when the water goes in, what it does is it swells. So it's all based on the amount of water that's actually present.
However, if we place the plant cell into a concentrated solution, then water moves out of plant cell by osmosis, and this causes the cell to shrink. So in this video, we're looking at how to investigate the effect of osmosis on plant tissue. The plant that we usually use is a potato, but this also works well using other vegetables such as beetroot or parsnip. First, we peel the potato. That's because the potato skin can affect osmosis. Next, we
so what you've got to do is you've got to remember that the potato skin around the outside doesn't let water in and out, right? So if you think about it, if you have a potato under the ground, right, what will happen is that potato wouldn't let water in and out. And if it did, it would just keep on swelling up and being really horrible. So the potato skin protects it. That is then your cork borer, right, to make exactly the same size cylinders.
Use a cork borer to produce 3 cylinders of potato. Using a cork borer makes all of the cylinders the same diameter. We then use a scalpel to trim the cylinders to the same length. Around 3 centimeters is a good value. If we use shorter cylinders, then we might not be able to measure the effect of osmosis. Next, we measure the length of each cylinder using a ruler and the mass of each cylinder using a balance. We now place each cylinder into a test tube. We then add 10 centimeters cubed of 0.5 molar sugar solution to the first test tube like this. We then add 10 centimeters cubed of 0.25 molar sugar solution to the second test tube, and then finally 10 centimeters cubed of distilled water to the third test tube. The reason that we use distilled water rather than tap water is because distilled water contains no dissolved substances, and they can affect the rate of osmosis. We now leave the potato cylinders overnight to allow osmosis to take place. Next, we remove the potato cylinders and we gently roll them on a paper towel. This removes any surface moisture. It's really important at this stage not to press on the cylinders. We want to remove surface water, but not force water out of the cells. Finally, we measure the length and the mass of the cylinders again. At this stage, we need to calculate the percentage change in length and mass. So we're going to look at that now.
Right. Now, before we do that, so before we watch the rest of that little video there, right, what I've got then is, this is then a results table, right? And in a minute, what I'm going to be doing is I'm going to be asking you to actually write this or copy this results table down into your exercise books. Now, you guys are obviously doing it now at home. Everybody else is then going to have to watch this video and they're going to have to do it themselves. Okay? So, these, to start off with, and I need you just to write this down after your method, is I want you to write down results. Don't need to do the table yet, but there are 3 equations that you need. Okay? Mohammed, can you turn your voice thing on again, please?
Yes, sir.
Hi, Mohammed. Right, just for everybody else, what I'm going to do is I'm going to use Mohammed as the guinea pig, right? Because I know he's amazing at this. So underneath the title, right, results, I want you to write down yellow equation, and yellow equation. And what I'm going to do is I'm going to ask Mohammed, right, to tell me when he's done. All right, so everybody then needs to kind of work at about the same speed. Okay? If you're unclear, just unmute and then just ask the question.
I can't see him.
Can't see them?
No.
Right, can you see, what can you see?
It's all like blurry.
All blurry. Mohammed, is yours blurry?
No, sir.
Right. Well, is that scarlet? Right.
Yeah.
Well, if can you see the words at the top here? But you just can't see
yeah.
the yellow.
No,
Right, okay, well, if I read them out to you, right, and then directly under where you've got your writing, right, then what I'll do then is I'll just read them. So the first one here, it says, change in mass equals final mass take away starting mass. Tell me when you're done. So change in mass equals final mass minus starting mass. Okay, Scarlett?
Yeah.
Right, so basically what that means is you're looking at how much it's gone up in weight or gone down in weight. The second one is percentage change in mass equals
Yeah.
change in mass times 100.
Sir, I finished it.
Okay. Start, ready for the next bit? Divided by starting mass. Are we ready? Okay, third one,
Yeah.
and what we've got to do is we're going to be using all these for a results table in a minute. The third one is rate of osmosis equals change in mass divided by time. So those three need to be written down in your exercise books and the results table we're then going to be using. Have you got all that, Scarlett? Nice one. Right. Everybody else, if anybody else has got any other questions, unmute now, right, and ask. Right, and then what we'll do is we'll carry on. Okay, brilliant. Right, now, Scarlett, can you read those? Right, now what I'm going to do is I'm probably going to give you about, 10 minutes, 5 to 10 minutes. This is a results table that you're then going to need to be writing down. And just like I said, everybody's going to be doing exactly the same thing. These are results that I've then got, right, from the exam board. We are then going to be calculating these two things here. So in your exercise books, you can take up a full page if you need to, draw that table out for me. Okay, and then Mohammed, right, do the same thing again when you've finished, right, let me know.
All right, sir.
Cheers. Don't forget pencil and ruler, it's got to be neat. No excuses just because you're at home. You're doing a lot of signing there, Mohammed.
All right, so I'm finished.
You done it?
Yeah.
Okay. I'll just give everybody maybe a couple of minutes. Okay, and then after a couple of minutes, if somebody hasn't finished, then they just need to unmute. Right, okay, so everybody at home, if you haven't finished, right, just unmute and let me know. Okay, good. Right, now, what you should have now is you should have that table that's then written down. Right, these are results from the practical that we've then been doing. right? What we now need to do is we need to fill in those columns and those columns, right? Now, these are the sort of questions you'll get asked in your exam about it. The first one we're going to do is percentage change in mass. Now, if you remember those first three equations that we did before, one of them was percentage change in mass equals to change in mass divided by the initial mass times by 100. So basically what that's saying is, that's the starting mass. It's gone up by that. What percentage has it gone up by? So literally, what you do is to work out the percentage change in mass, you do change in mass, oops, wrong order. You do change in mass, which is 0.11, divided by initial mass, which is then over there, which is 0.88, times then by 100. Okay, that's supposed to be a times. All right, and then what you then do is you do that, there's then like a sum, and I think it works out to be 12.5%. Okay, now what I'm just going to do is I'm just going to do the sum for the next one. In fact, I might do the sum for this one down here, right, and then I'll give you about 3 or 4 minutes of working out, and then hopefully I'll be able to ask some of you at home the answers to the questions. So this is one here, the 0.75. Change in mass is minus 0.25 divided by mass of the potato at the start is 0.94 multiplied by 100 equals, okay, and your answer will be minus. And the minus basically tells you that it's got smaller. Okay, so maybe 3 or 4 minutes, come in your calculator, or you can use your phone, because obviously I'm not going to take the phone off you, right? What I want to do is I want to calculate those 4 there, please. If you're stuck, unmute and ask a question.
I can't read the numbers.
You can't read the numbers on the table?
I can't read the numbers where you...
Or the numbers that I've written?
Yeah.
Right, okay. Can you see where I'm pointing? Can you see my writing appearing on the pen on this thing there? Is it because of the colour? Right. If I rubble that out. Right, can you see this now? Can you see that? Yeah, so this is the first one. 0.11 is the change in mass, and I'm doing it from the equation at the bottom here. Divide that by the starting mass, which is 0.88, times by 100 equals, and I think in my calculator it works out to be 12.5%. Okay. Then what you need to do, Scarlett, is you then need to do 1, 2, 3, 4, same sum down the others. Can you read those numbers now?
Yeah.
Okay, brilliant. Right, a few minutes, just get on with that, please. Jack, have you got a microphone? Nimra, have you got a microphone?
Yeah.
Right, I'm going to ask you one of these in a minute. Are we okay?
Yeah.
Right, so this second one down here, right, the one that's 0.02, tell me what I'll write.
Would you write 3.9?
What, which one? This
Zero,
second one.
3.90. Yeah.
Well, what's my sum that I actually write? So what's the change in mass?
Would you times it by 0.02?
Yeah. Divided by?
0.76.
Brilliant. Multiply it by?
100.
Fantastic. And the answer is?
Would it be 3.90?
3.90. Okay, is that what you said right at the very start? Yeah. Okay, 3.90%. Right, well done. So basically what that means is change in mass, it's gone up by 3.9%. And you can see this one, or the first one, the 12.5%, has gone up a little bit bigger. Mohammed, what's the sum for the third one down, please?
Minus 0.12
Good.
divided by 0.67
Good.
times by 100,
Good.
which equals 17.91045. It gave me minus 17.91045.
Oops. Sorry, I've just gone across one. Let me just go back. What do you say, sorry? Minus?
17.91045.
Okay, that'll do. So basically, that one means then it's gone down, the actual change in mass has gone down by minus 17.9. And what you need to do is you need to think about then what's actually happened. So if it's got bigger, that means water's gone in. If it's got smaller, then water's come out. Scarlett, what's the bottom one, please? Scarlett, can you hear me?
I didn't do the bottom one first.
You haven't done it yet? Right, I'll just do the sum so we can move on. So 0.43 divided by 1.01 times by 100. Mohammed, what's the answer to that? I haven't got a calculator with me.
That's minus 42.5.
42.5. Okay, percent. Okay, and then Nimra, have you got the answer to this one here? Minus 0.28 divided by 0.94 times by 100.
Would it be 500?
500. That'll be 500.
Yeah, that's not
Right, so put in your calculator, oh, mine's working now. Minus 0.28 divided by 0.94 times by 100, and then so that one should be 29.8%, or minus 29.8%. Okay, so the key numbers that you've got down here now, right? Hopefully Scarlett can see them. In fact, I'll do them in green. The key numbers that should have in those boxes there are that one, are both positive, that one, and that one. They then show the percentage change in mass. What you can do is you can see that's got heavier, so therefore water's gone in. That's got heavier, water's gone in, but not as much as that one. That one's got lighter, that one's got lighter, and that one's got lighter. Now, just on a piece of paper at front here, what I'm just going to double quickly do is write these numbers down. Okay, for the next slide. 12.5, 3.9, minus 17.9, minus 29.8, and minus 42.5. Okay, now, next thing we're going to do is we're going to do this rate of osmosis. All right, this is then probably your grade 5 question if you're going to get asked about it. Okay, now, the rate of osmosis, the equation at the bottom here that you've already got written down, is change in mass divided by the time. Okay, change in mass divided by the time. Okay, so for this one, what we're then going to do, let me just change the colour again, go back to black. Right, so we've got these here, so we've got in that box there 12.5%. Okay, the rate of osmosis, we've then left it for 24 hours. So to work out the rate of osmosis, what you do is you go to change in mass, which is, 12.5, divided by 24 hours, equals, I'll just do that on my calculator. I'll just turn the calculator off. Is 12.5 divided by 24 hours equals 0.52 per hour. Okay, so basically it's 0.52 per hour. Then what I want you to do is I'm going to do that box, that box, that box, and that box, or that box, that box, that box, and that box. And what I'll do in a second is I will then be asking you the questions again.
Sir, I don't get it.
Okay, sorry, just pop that in the room for a second. Is everybody okay? Just don't say anything if you are. Hello.
Sir,
Yeah. Right, we're with you in a
I
sec.
don't understand the work.
Okay, I'll be with you in a sec. Right, Mr. Wilson's in the room at the moment. Well, he's not downstairs now. Come to the room and get it, and you walk my house.
Yeah. Okay.
I can't do it, the printer rooms. Did you want,
I'll just do it off the screen now. That's all right.
you want the room in front of block?
No, we just
Leave it there anyway. He's not going to leave it. Right, I can't now. Okay, right, who was it was asking? Right, if I get to the next one, just on freeze at the moment. Okay, so we've got those results down there. So that one there is 3.9%. To work out the rate of osmosis, you're literally doing the change in mass. So this is to find out how fast osmosis actually is. You do 3.9 divided by the time that we actually did the experiment for, which was 24 hours. That then equals, I'll just do it on my calculator here now, that equals 3.9 divided by 24 equals 0.16 per hour. Okay? Right, so I'll give you another minute, and then what I'm going to do is I'll ask those people that have got mics, right, just to tell me what answers they've got down there. Okay, right, Mohammed, right, in this box here, right, what am I going to write?
Okay, so you do minus 17.9 divided by 24 hours,
Good.
which gave me minus 0.745.
745. Okay, we'll just do it minus 0.75. Okay, brilliant. Nimra, this one here, please.
So I didn't do it.
Second, sorry. So change in mass, what's the percentage change in mass?
Is it 27.8?
So it's 29.8, which is the change in mass, divided by
24?
24 equals,
Does it equal 1.24?
minus 1.2. Okay, don't need too many decimal
Yeah.
places. Right, good, well done. And then the last one, I'll just write down the answer for it, it's minus 1.77. Okay, so what you've then done is you've then worked out the rate of osmosis in those individual questions there. Okay, now, last thing that then we need to do, what, you want it?
I got
Who was that? 1.9. If I just do the sum again, I might have a number going on. So it would be 42.5 divided by 24 equals, I've got 1.77 for that last one. Minus 1.77. Okay? Right. So just make sure you've got those numbers written in. Now, next thing that we then need to do is draw a graph of it. Now, I know you're not going to have graph paper at home, right? However, if you just turn your exercise book sideways and you kind of just do it as like a full page in your exercise book, what we're going to do is we're going to do change in mass against concentration of sugar solution as a percentage, right? Now, obviously it's going to be quite difficult for me to actually show you as an example, right? But this point over here is 0. So basically what that means is the potato hasn't changed size. And what I'm going to do is, I'm just going to click back, okay? And my percentage change in mass, the biggest one is 12.5. Right, so what I might do is, and you're going to have to do this in your own way in your exercise books, is I'm going to go 5, 10, 15. And obviously you have to spread those out in the correct way. So it's exactly the same gap in between. When the percentage mass negative is then down to minus 42.5. Okay, so minus 5, minus 10, it's going to be a bit bigger, 20, 25, 30, minus 35, minus 40, minus 45. Okay, so you just need to think about it a little bit before you actually start doing it. Then, concentration of sugar, the one that goes across the middle, what we've got is that is then these around that side there, which is your 0.25, 0.5, 0.75, and 1. Okay, so start at 0 here. Right, then you can evenly spread out 0.25, 0.5, 0.75, and 1. Okay, they are then all the results that you've then got. Once you've set this graph out, then you need to then start plotting your results. So 0% sugar solution has a 12.5% increase. So 0 goes up to 12.5, which is approximately there. Now, it should actually be on the line itself. Then I'll just give the next one as an example, and then you're then going to have time to draw this yourself, which is then 0.25. So I'll go back to the table. 0.25. It then goes up for 3.9%. So on your graph, 0.5 goes up approximately 4%. Your graph will be better than this, okay, which then goes to there. Then you do 0.5, 0.75, and 1. This here, draw a line of best fit, curved or straight. What you then need to do is you then need to get a ruler over the top and then draw a line through as many of the crosses as you possibly can. And once we've done that, then it's going to be the end of the lesson. Anybody got any questions?
I can't see where you was writing.
Is it because I'm doing it red every time? If I do it black, right, so
I can't see where you
5. Can you see the graph?
No,
So what can you see on the screen at the moment?
it's like half of the graph.
About half of the graph.
Yeah.
Right, you need to try and change the resolution on your screen or whatever it is. It may well be screen that's a problem. Now, what I am going to be doing is, in about 2 or 3 minutes when I stop the video, right, the video is then going to be downloaded, right, and you'll be able to watch it. Right, so if you can't do it at the moment, Scarlett, right, then what you might have to do is just come back to it in about 10 or 15 minutes, unless you've got another lesson on, and then you'll be able to see the graph. Okay? Can anybody else not see it? Right, I know it's difficult drawing the graph in your exercise book, right, and it's just kind of what we need to do at the moment. Right, now what I'm going to do now is I'm actually going to stop the presentation, right, but basically what I want you to do, unless you've got another lesson that's appearing soon, because this is now your break, right, what I want you to do is I want you to finish that graph in your exercise book, okay, and then we'll have to just wait and see who's in tomorrow, okay, because they're just doing the search at the moment. Right, has anybody got any questions before I stop the lesson? Okay, right, that's brilliant then, guys. I don't think we've got a lesson tomorrow anyway, right? It may well be on Wednesday after that. Okay, cheers, guys. Thank you very much for logging in.
Okay, thanks, sir.
See you next week.